So good day everyone. Welcome to our review session. I am Miss Rayan and for today our topic is about evaluating different forms of function. Okay, so let's start. So our learning objectives is at the end of this module or at the end of this lesson, learners should be able to recall the difference between function and relation, recall the different forms of function, and evaluate a function. So let's start. Let's start by differentiating relation versus function. Okay, so we have here a table for us to simply differentiate the difference between relation and function. So first, relation is a rule that relates values from a set of values called the domain to a second set of values, which is the range, while function is a relation where each element in the domain is related to only one value in the range by some rule. Next, for the relations, the element of the domain can be imagined as in-out to a machine that applies to rule to these inputs to generate one or more outputs, while function, the elements of the domain, can be imagined as input to a machine that applies a rule so that each input corresponds to only one output. Okay, and relations is also a set of ordered pairs, which is x and y, and functions is a set of ordered pairs have the same x value but different y values. Okay, magkakapareha ang functions sa mga x values, yung nauunang values sa ordered pairs, at pwedeng na magkaiba-iba sa values ng ating y. Okay? Now, what are some types or what are the forms of functions? So let's start with linear function. So a linear function is a polynomial function having the first degree equation, having the first degree or yung highest degree sa isang function ay 1. So we have an example here which is f of x is equals to 2 and f of x is equals to 2x minus 1. So as you can see here, the highest degree is only 1. So the next type of function is what we call a quadratic function. So a quadratic function has a second degree, okay, and it has a graph of in the form of curve. So by the way, this type of functions is in the degree types, okay? Yung equation type nila, yung highest degrees nila. So for the quadratic function, sabi dito, ang kanyang highest degree ay squared or number 2. Number 2. So we have here the general equation. So we have f of x is equals to x squared, ax squared plus bx plus c, wherein a must not be equal to 0 and b and c must real numbers. Alright, and then we have here an example, which is f of x is equals to 3x squared plus 5, and f of x is equals to x squared minus 8. So as you can see here, our highest degree is 2, which that's why we called it quadratic function. Next, we have here a cubic function. A cubic function has equation degree of 3. Okay? From the definition except cubic, ang ating highest degree ay cube or number 3. So we have here a general form which is f of x is equals to ax cubed plus bx squared plus cx plus d, wherein a must not be equal to 0 while our b, c, and d must a real number. So we have here an example which is f of x is equals to a x cubed plus 5x plus, I'm so sorry, saying the call, 5x squared plus 3. So as you can see here, we have 2 degrees, which is 2 and 3. But the highest degree in this function is 3. So this is an example of a cubic function. Alright, next, we have here a polynomial. I'm sorry, it's wrong. There's wrong spelling, but polynomial function. So we have here a long general form here, and based on the highest power or the highest exponent of the polynomial function, the functions can be classified as quadratic function, cubic, and etc. So this type of function exceeds to highest degree or exceeds to 3. Okay, so for example, our highest degree is raised to 4, then that is an example of a polynomial function. Okay, so those are the types of the polynomial functions. We have linear, quadratic, cubic, and polynomial function. Okay, now let's proceed to our main topic, which is evaluating functions. So what is evaluating function? So this means replacing the variable in the function. Okay, we are replacing, or in other words, we are substituting. Okay, so to denote that we are evaluating f at a, for some a in the domain of a, we write f of a. So for example, f is the function and a is the value, so we just substitute the a to the value of a function and we conclude for f of a. So here are the steps to evaluate a function. So first, we should directly replace or directly substitute the indicated value to the given function. Next, to perform the indicated operation, whether it is multiplication, division, addition, and such, and let's simplify the answer. So that simple it is to evaluate a function. So let's have an example. So we have here an example. So evaluate the function f of x is equals to 4x plus 1 at x is equals to 2. So how will we do this? So the first step we have here is directly replace the value by 2. So like this, okay? We replace the value of 2, we replace the value of x, which is 2, to our function. So our new function is f of 2 is equals to f multiplied by 2 times 1. Now, next step is to perform the indicated operation and simplify. So let's multiply 4 times 2 plus 1. So we get 8 plus 1. Now, for our simplified answer is 9. So for our final answer is f of 2 is equals to 9. Okay, simple as that. So let's have another example. So our function is g of x is equals to 2 plus x minus x squared. What is the value of x is equals to negative 3. Okay, so this is an example of a quadratic function since our highest degree is 2. So the first thing we're gonna do is to substitute or directly replace the value of x to our function. I'm sorry, this is supposed to be g of x or g of negative 3. Okay, so we replace the value of negative 3 to our x. So now we have f of negative 3 is equals to 2 plus negative 3 minus negative 3 raised to 2. Okay, this is raised to 2. Now, let's perform the different operations. So we perform first this. So we have to square this first, which is negative 9. And then we simplify the values, which is 2 plus negative 3 plus 9. So we conclude to our answer, which is negative 10. Now, so the value of f of minus negative 3 is negative 10. Okay, simple as that. So for this function, g of x is equals to 2 plus x minus x squared. I'm so sorry. X squared. What is the value of g of negative 3x is negative 10. Okay, let's have another example for us to fully understand it. So we have here, evaluate g of x is equals to the quantity of x squared plus 1 multiplied to the quantity of 3x minus 5 as x is equals to 4. Now, this is, if we can simplify this binomials, right? It is an example of a cubic function. Okay, so instead of simplifying it like this or using the FOIL method, we can just substitute or replace the value of x directly. Okay, so for our problem is like this. We are going to find the value of g of 4. Alright, now let's substitute the value of 4 to our function. So as you can see here, we already substituted the value of 4. Now our new function is g of 4 is equals to 4, the quantity rather of 4 squared plus 1 multiplied by the quantity of 4 times 3 times 4 minus 5. Okay, let's perform the given operations. Now we just simplify first this parenthesis, so we concluded for 16 plus 1, and then for this quantity or for this parenthesis we concluded with 12 minus 5. Okay, so 16 plus 1, we can simplify it, and 12 minus 5, so we have 17 and 7. By performing the operations, we just have to multiply 17 by 7, and now our g of 4 is equals to 119. Okay, so simple as that. Okay, first, so that's all for our examples. Okay, remember, again, to evaluate the function, first we should have directly replace or substitute the indicated value to the given function and perform the indicated operation and simplify the answer. Okay, so I hope you learned something from this review session, and have a nice day, everyone.